So welcome everybody to this latest A2 video on trigonometry, and in this video we'll be focusing on or introducing harmonic form, also known as the R addition formulae, and showing you how to factorize an expression into this form. Now, a special technique is used to express an expression involving single sine theta and single cos theta into a single trig function of cos or sine, therefore making it easier to picture, equate and solve. So these here are now our harmonic form, or new sets of sort of R addition formulae as they're sometimes known as. So here we've got a cos theta plus or minus b sine theta equals r cos of delta minus plus alpha, and then we've got a sine theta plus or minus b cos theta equals r sine theta plus or minus alpha. Now you might be thinking to yourself, well, surely the right and the left hand side are the same. There's a slight tweak in this, and that's because it's kind of connected to our double angle identity, which we will kind of remind ourselves with when we look at some examples. Another key note of this is that a and b are going to be positive, where alpha is an acute angle. Now sometimes it will tell you in the question you're working for that alpha is acute, or alternately what they could do is give you a range of what alpha is. So it could be, let's say, like theta a 0, alpha is between like so. So this indication will tell you that alpha is going to be one single value that we're looking for rather than a range of values, which may go on to when we look at solving equations, which will be in another video. Now, to identify each of these identity questions will involve often request that an expression be written in either of those forms. So you may be thinking to yourself, well, hang on a second, how do I know which of these trig identities or these R addition rule formulas to use? Well, it will always give you that and specify that in the question, so fear not. So let's have a look at what a typical question would look like. So a typical question would read, so write an expression of 3 cos theta plus 4 sine theta in the form of r cos theta minus alpha. So in this, what we need to do is, here is our expression. This is our end result, what we want it to look like. And what we need to do is we need to find alpha, and we need to find the value of r. We don't need to pay too much attention to theta, because that's what we were going to go on to find. So we want to make this look like this. Now there's several steps in which you can do this, and it doesn't really matter which one you try and find first, whether it be alpha or r, whichever takes your fancy. So let's have a look at finding a. Now the first thing you want to do, like I always prefer working in steps, so to find alpha, what you want to do is make the expression equal to the harmonic form. And what do I mean by that? Well, I mean I want to make this equal to this. So what we've got then is we're going to have 3 cos theta plus 4 sine theta equal to r cos theta minus alpha. Now the next thing we then want to do is then use the double angle, or just say the compound, use the compound identity for the right hand side. So what we're going to do is then, we know that from our compound angle formula that cos alpha plus beta equals cos alpha cos beta minus sine alpha sine beta. So I'm going to use this and replace it with this here. So what I've then got is I'm going to have 3 cos theta plus 4 sine theta is going to be equal to r, and I'm just going to put that in brackets, and it's going to be cos theta cos alpha minus plus, and let me just make sure correct. So we're going for plus. Now it's always worth, just be careful with when using the cos formula in particular. So here we've got 4, and it's going to be sine theta sine alpha. I'm just going to make a little note of that, of be careful with the middle sign when using cos. So from this, what I can then do is our next step is to expand the right hand side and compare the coefficients of cos theta and sine theta. So what I'm going to do here is expand the right hand side. So what I've got is I've got 3 cos theta plus 4 sine theta equals r cos theta cos alpha plus r sine theta sine alpha. Now from this, what I then will do is compare the coefficients. So I'm going to do just rejig these two things around and those two things around, so it just makes a little bit more sense of what I'm doing next. So here I've got r cos alpha cos theta plus r sine alpha sine theta. Now in terms of comparing the coefficients, what I notice is that this 3 must be equal to this. So here we've got 3 equals r cos alpha, and comparing the other coefficient, I've got 4 must equal that. So here 4 equals r sine alpha. And what I'm going to do is I'm just going to make a little note of that. So let me just put a little hashtag 1 on there, because we will be coming back to that when we're looking at finding r. Now the fourth step is then use tan theta equals sine alpha over, tan alpha equals sine alpha cos alpha. Find tan alpha and then find alpha. So from this, what I'm going to do is I'm going to use these two things here. So I know that r sine alpha over r cos alpha is going to equal 4 over 3. Now from this, I notice that the r's are going to cancel out, and sine alpha plus over cos alpha is going to give me tan alpha. So this is what I've got. And then from this, what I can then do is that alpha is going to equal the inverse tan of 4 over 3. And because I know that alpha is going to be acute, so all I'm doing is just trying to find the acute version of tan 4 over 3. So on my calculator, inverse tan 4 over 3, and it gives me an answer of 53.1 degrees to 1 decimal place, and there is my answer for alpha. Now for when finding r, we can do this in a number of ways. Now the most common way, if you're going to do this first, is here. So using that r cos alpha, and that was 3, and r sine alpha equals 4. So here what I'm going to do is, and this is going to be step 1, is then square everything, square and add. So what we're going to do here, so here I've got r squared cos squared alpha equals plus r squared sine squared alpha, and that's going to equal, well, this squared equals 3 squared, and this squared equals 4 squared. Now from this, what I can then do is factorise. So here, step 2 is then factorise the left hand side. So what I end up with is r squared equals cos squared alpha plus sine squared alpha, and that's going to equal 9 plus 16. So here, this all using identity equals 1. So what I've got is I've got r squared equals 25, and therefore r equals the square root of 25, so r equals 5. Now you might be thinking plus or minus 5, but here r must be positive because it represents a length. And then just to finish writing that all up, what we've then got is we've got 3, and let's go back to the original question. There's 3 cos theta, 3 cos theta plus 4 sine theta can be written as 5 cos, and it's going to be theta minus, and the angle was 53. And there is my final answer. So now let's have a look at our second expression, and this expression here, what we're doing is we're working with sine. So again, depending on which one to choose. Now, in terms of a shortcut of finding r, well, basically r is always going to be r squared will be this number squared times this plus this number squared. So here in terms of our cos, if I just take those two numbers, r squared is going to be 2 squared plus 3 squared. So r squared equals 4 plus 9. So r equals the square root of 13. So it's a quick way. You don't have to show your full working out for r, but like I said, in an ideal situation, this is something that you will spot with more practice. Obviously, it's best to show as much working out as possible, but if you really push for time, then that does work. So let's have a look at working this out. So first thing I'm going to do is find what alpha is. Again, looking at this, I'm going to do 2 sine theta plus 3 cos theta equals r sine theta plus alpha. So again, they've already told me that the sines are what I'm going to use. Now, in terms of this, I know that this here is sine alpha, sine theta cos alpha plus cos theta sine alpha. So in substituting that all in, what I get is I get 2 sine theta plus 3 cos theta equals, and it's going to be r lots of sine theta cos alpha plus cos theta sine alpha. Next thing I then want to do is expand those brackets. So I've got r cos alpha sine theta. Now just rejig, swap these two things around, just make it easier when I'm comparing the coefficients, equals r sine alpha cos theta. And again, what I then want to do then is compare the coefficients. So 2 is going to be equal to this, and 3 is going to be equal to this. So here I've got 2 equals r cos alpha, and I've got 3 equals r sine alpha. So then using both those two things there, what have I got? Well, I've got r sine alpha over r cos alpha equals, with the r's cancel out, equals 2 over 3, which equals tan alpha. So tan alpha equals, it's going to be 2 over, or it's 3 over 2 rather. 3 over 2. Then alpha equals the inverse tan of 3 over 2. And if I type that into my calculator, what do I get? Well, I get inverse tan 3 over 2, which equals 56.3. 50.3 degrees, and that's to 1 decimal place. Then obviously finding r. Now again, you can use the way that I showed you. So here we could have known that r squared equals 2 squared plus 3 squared. So r squared equals 13. So r equals the square root of 13. That's absolutely fine. But if you want to show full working out, then again, it's entirely up to you. All we've got to do is just use these two things here, square them and add them. So here we've got r squared sine squared alpha plus r squared cos squared alpha equals, and it's going to be 3 squared plus 2 squared. Then r squared equals sine squared alpha plus cos squared alpha equals 9 plus 4. And then r squared equals 9 plus 4. R squared equals 13. So r square root 13. So from using those two values, what I then want to do is then substitute it in. So then what I've got as my final answer is, just going back to see what the original question was, so it's 2 and 3, so 2 sine theta plus 3 cos theta equals the square root of 13 sine theta minus 50. There is my final answer. Now we'll put a worksheet which gives you
chance to practice everything that's covered in this video, to at least factorise it into harmonic form, and obviously I'll include the answers in there to make sure that for you to check, make sure that you are getting it correct.